Hello everyone, this video is regarding Lab 8 of EE542 Internet and Cloud Computing. It is AWS EMR Spark Programming. My teammates are Aswathi, Dhrumil and I am myself Prem Kumar. The goals of this project is implementing a simple Spark programming to look for a string pattern in the provided dataset and return the string IDs that contain the required pattern. In the second part of this project, we modify the sample code that is given to us to look for all the person's name that have the empty ND4 gene in the provided data sequence. We need a S3 bucket to hold the output and input files for the EMR cluster. So I go to my AWS console and create an S3 bucket. So create bucket, I give a name lab 8 EE542. And then let me change the region to North California. Next, and then this remains the same. This I give the grant the Amazon S3 log delivery group right access to this bucket. Then next, and then create bucket. So now as you can see, the bucket has been created. I need to upload the files that are required. So I go to the upload thing, drag and drop here, or add files. Let's add files. So here in the download, I select this string data.dms that is required, and the next thing that is to be uploaded is the pattern search Python code. So I upload this. So now my S3 bucket is ready for use.
The second step required for EMR is creating EC2 instance, where a key will be generated. It should be downloaded on the same machine as it is private. This key needs to be linked to the EMR cluster. Now let us see the procedure for creating and launching an instance. In this, we will be selecting the first one, which is Amazon Linux 2 AMI. And for this, we need the type 2 micro with 1 GB memory, and the version of the CPU should be 1. Now we will do review and launch. Let us launch this instance. Now we will have two options. Either we can choose an existing key pair or we can create a new one. So for this experiment, we will be creating a new key pair. Let us name our key lab 8 key 01. Now once this key pair is downloaded, it cannot be duplicated or it cannot be transferred to any other laptop other than this. Launch instance. Now we can see that one instance is pending. It should be in the running state in order for us to continue with this lab. As you can see, it is in the running state now. Now we finally create the EMR cluster where the EC2 key will be linked. Now let us see the procedure for creating the cluster. Click on create cluster. For the name, we can give it as lab 801. And the default storage folder which is used is of the S3 folder. For software configuration, we will be selecting Spark 2.3.1 on Hadoop, and for hardware configuration, we will select the instance type to be m4.large, and we will be creating 3 instances, of which one will be master and 2 core nodes. Now for security and access, the EC2 key pair, we will select the one we had generated for this experiment, which is lab 8 key 1. We will keep the permissions in the default settings and create cluster. As you can see, this is in the starting state right now. It needs to be in the waiting state for us to proceed with the experiment. As you can see, the cluster is in the waiting state. In order to execute the SSH commands, we need to enable the SSH protocol for this PC's IP address. For that, we will go to the security groups for masters. We need to change two settings, that is, for master in inbound, we need to add one more rule, which is for the SSH commands. Now we need to do the same steps for slaves as well. Add rule.
After creating the S3 bucket, launching the EC2 instance and creating the EMR Spark cluster, we need to connect to the master node of the EMR cluster. For that, we need to run the SSH command. The command is -i is for the identity file. Now we will add the path to the private key what we generated in the EC2 instance. Now we will add the master public DNS address for the master node what we created in the EMR cluster. Okay. So we have connected to the master node. As you can see the EMR on the terminal. Now we need to test for the part 1. So we need to run the command. The command goes as so the number of executors we are giving as 2, the cores is 2 and the memory is 5G. And now we will give the part to our source code. This is the S3 bucket what we created. And this is the source code. Now this is the part to the input file, which is string underscore data. And now we'll give the part to the output file or the output folder, which we have not created. It will be created by itself. So just check once again. It's spark hyphen submit space hyphen hyphen deploy hyphen mode space cluster space hyphen hyphen master space yarn space hyphen hyphen num hyphen executor space 2, that is the value, space hyphen hyphen executor hyphen cores space 2 space hyphen hyphen executor hyphen memory space 5G, then the path to the input source file, the part of the input file, and the part to the output folder. So now it is running. You can see the procedure. The process is complete. As you can see, the final status is succeeded. Now we can check our S3 bucket. So yeah, so you can see in the S3 bucket the output folder is created, and over there's a success and part 0000. So when you select that and download it, and when you open it, you can see, so we got the output as 6RZH. This is the name of the patient, or the name what we need to search using the search pattern. So the first part is completed, and now we'll move on to the second part for the DNA genome analysis.
In the second part of this project, we have to download the DNA sequence of 1131 people from EMTDB. So I go to the EMTDB website and download using download faster. Now the whole file has been downloaded and it is available in my computer. Then the next thing is to search for the MTND4 gene, the sequence of which is obtained from this website. Let's go to that website, and the sequences as seen here, it is the Homo sapiens mitochondrial complete genome.
In this part of the experiment, we are creating another folder within our S3 bucket named DNA. So in the folder, this is done to perform our designated experiment for the search of the NTD4 gene. In this, we will upload the modified Python source code and the patient database. So this is the source code, and this is the database. In the patient database, the name of the patient is identified by a string which may or may not be their name. And in the search code, the search string is the sequence for the MTND4 gene which we need to search in the patient database. So to test our modified pattern search program, in order to find the list in the database for the MTND4 gene, we will run the previous command again. The variables will change, the name will change, but the attributes will remain the same. So this is the part to the source code. This will be the part to the input. And this will be the part to the output, and we don't need to create the output folder, it will be created automatically using this command. Now we will execute this command. So as you can see, it is running. The libraries have been loading and the required cluster is being accessed. So you can see it is accepted, and now after the accepted command, after the accepted state, it will go in the running state. So see, it is in the running state, and after the process is complete, we'll get the final state that succeeded. So as we can see, the process is completed. We got the file state as succeeded. Now we need to check the S3 bucket for the output. So we can see the output folder is created by itself, and you have the success notification, and this is the file. And when we open the file, you can see this is the list. This is the list for all the patient string name, which has the empty ND4 gene. And as you can see, the list is also sorted in the alphabetical order. So from the entire patient database, this list was done.
Experiment is complete. We successfully found out the list of patients having empty ND4 gene using EMR cluster. Thank you for watching.